What is a unit cell? Well, here's a lattice and it has a simple cubic structure. Other structures are available. For example, the element polonium has this structure. Now this big green cube, if I break it into smaller green cubes and put it into the lattice, these are going to be the basis for this unit cell. So there in pink is indeed the unit cell. At the corners of the cube is 1/8 of an atom in this case. And there is some empty space too. So what is a unit cell? It's the repeating unit in a lattice. So if I repeat this unit cell, I should get back the original structure, which indeed I do. Okay, except for the very, very edges of the structure. It doesn't work there. But remember, this is an enormous structure. And so essentially the insides are going to be perfectly modeled by this unit cell. So investigating further, we can see that the volume of the atoms in that unit cell is exactly one atom. It is 8/8 of an atom in the unit cell, which has the volume equivalent of one atom. So the volume of the unit cell is 2r cubed, r being the radius of the atom. And the volume of an actual spherical atom is 4/3 pi r cubed. So we can work out the volume of the unit cell actually filled by the atom by dividing one by the other. Now luckily everything cancels out to give you pi over 6. And in terms of percentages, 52.3% of the unit cell contains matter from the atoms, and 47.7% is empty space. You can also draw this unit cell in this dot fashion, which frankly is easier to draw, but less informative than the model we saw before. Another term you need to know is coordination number. So if I strip away the atoms or ions away from one single atom and its neighbours, I count 6 neighbours, and indeed that is the definition of coordination number. The number of nearest neighbours to an atom or ion. And we're done. That wasn't funny at all, Thornley. It took me so long.